Hey, this is Physics 2211 Lab 5 with the falling Slinky by Karthik Chilakapati. So, the purpose of this lab is to analyze the motion of a falling Slinky as it starts from being fully extended until it hits the ground. We will be observing the bottom part of the spring when it is fully extended. And fundamental physics concepts we used are V final equals V initial plus F net over M times delta T, so our velocity update formula, the force gravity formula, which is mg in the negative j direction, and our drag force because those are all the forces acting on our system. So the results were that since we were analyzing the bottom of the slinky, the graph was horizontal at first because the bottom of the slinky wasn't moving, and then it started decreasing. Initial conditions. So our initial position for the slinky was at the origin set at 0, 0, 0 meters, and the initial velocity was also 0 meters per second because it starts from rest, and acceleration was only gravity of negative 9.8 meters per second squared. The system we included was the slinky and the earth, and none for the surroundings. So our observational motion was like this. We took the video from YouTube and put it into Tracker and analyzed the motion of the bottom of the spring. And then our computational model, I set for two different time periods of less than 5.6 seconds and from 5.6 to 8.8 seconds. This is when the bottom of the spring was not moving, and this is when the bottom of the spring started falling towards the ground. And we have two different force net equations we created here based off the situation that was in both scenarios. And comparing both of them, here we have our observational model. We can see that at around 5.5 seconds, it starts to decrease downward, like the bottom of the spring starts to move towards the ground. But over here in our computational model, it says that it would start around more closer to 6 seconds rather than 5.5. And possible errors here are that calculating the drag force may have been wrong because we estimated what the B value would be, and negligence of any other possible forces that we may have oversaw in the experiment. So our what if question is, what if the Slinky was released uncompressed? I was assuming that maybe it would fall uncompressed all the way to the ground and have a curving graph for position versus time because it would be accelerating and not moving in like different segments. And what does it mean when each part, like what does each part of the graph represent? I said that the flat part represents when the segment from where the spring was released and until it was fully compressed. So when the bottom of the slinky was not moving. And then the decreasing segment represents the part where the slinky was fully compressed in the air to fully compressed underground.